Thanks for having me on a Friday night, dark here Friday night. And I do remember that 2015, that was seemed like such a long time ago. Um, but I'm here in the soil teaching lab tonight, just so you can see this is where we normally teach our soil labs. And I have some stuff I want to show you here, and we're going to get into the lecture right away. But I just wanted to let you know I teach introductory soil science classes. Yes, I've run the student farm now for over 23 years, and I'm a volunteer here. In fact, our last Thursday night before the time change, we had over 91 students out at the student farm. And we feed them every Thursday night. So we're out at the student farm, 4:30 to dark, hot supper at around 6 or 6:30, depending on what time of year it is. And we completely volunteer and we self-sustain by selling fruits and vegetables to customers through the CSA program. Anyway, that's kind of my passion for sure, is working with students. And I threw in with students a long time ago here at the university, and I really never looked back. And this is really why I do it, is for these amazing people. What I want to talk to you tonight about soil, what it is, how it works, and I mean, really, it's all about soil. I know you've already heard that in the intro, but it is all about soil. And I don't just mean in agricultural aspect or uses, but I mean everything. It's all about soil. I mean, every atom in your body, has been through the soil billions of times already. I mean, the fact that you are not soil at this moment is a temporary condition, folks, and it's almost over. And I don't mean this talk. I mean your life. You're here, and most of the time you're soil, and you're down here, and you're having a little look around before you know it, it's over. So pay attention, because this is an important talk. And think about it. Here we are together at this moment in the history of the cosmos, at this time in the history of the cosmos, where we know so much more about everything than we ever did, even a couple hundred years ago. Most of what we're going to talk about here tonight, people didn't know. And for most of human history, people didn't know that. And yet here we are tonight in this moment, post-agricultural sort of revolution, to be able to experience this and on a Zoom call of all things. And I mean, maybe I should just get right to it. I mean, what soil is, and most people have most of you have experience with soil, and that's why you're probably here tonight, because you're gardeners or something. But what soil actually is it's made out of, I mean, maybe you don't know this, but rocks dissolve in water. And what a rock is made out of, and I happen to have a rock right here, and I've got a few rocks here, but what a rock is made out of is what rocks really are. Here, I have some rocks right here. These are just chemicals. That's all they are, different chemicals. And what they're made out of is basically the elements in the periodic table. And that's what everything is made out of. I mean, every atom in your body was once inside of a rock. And then it was released because rocks dissolve in water. And you can see these different rocks. Look at these different colored rocks. The reason they're different colors is because rocks are just collections of minerals. And there's different colored minerals here, and they're made out of different elements in the Earth's crust. And some of them are very fine textured rocks. Some of them have all these different colors, but these have different chemicals in them. And so the soils that form from these different rocks have different properties. And the nutrients, and that's really where the nutrients come from that make your body. I mean, every atom in your body, and I think I just recently read that your body is made out of 23 different elements and has 84 different minerals in it, secondary minerals that were formed from when you ate them. I mean, how you became what you are is, here's a rock, right? And rocks dissolve in water. And if you don't believe me that rocks dissolve in water, tonight, most of you are home right now, right? So just go get a little bit. Here's a little table salt. And all salt is is just sodium chloride. And here's some sodium chloride right here. And it's 2 elements, sodium and chloride. And put a little on your hand and then lick it. And that is a mineral that dissolved in water, in saliva, but it dissolved rapidly. And the first thing to dissolve out of the rocks is salt. And when the salt dissolves out of this rock, what it does, I'll put a little water on this rock. And even right now, a tiny little bit of salts have dissolved on this rock. Very, very, very small amount has dissolved out of this rock. And when that little bit of drip that just went down on this desk here is going to dry out, and there's going to be a little bit of salt there. And at some point, I'm going to wash this table down, and that's going to be in a rag, and I'm going to squeeze it out into the sink, and that's going to go down into the drain, which is going to eventually end up in the river. Or maybe this building will have some of those salts that were left here. They're going to tear this building down, or it's going to burn down at some point. And those little bit of salt is going to end up in the soil sooner or later. And that little bit of salt, every time it rains, is going to go a little further into the soil. It's going to go down, and it's going to dry out, and it's going to go down, it's going to dry, and eventually it's going to get to the groundwater. And the groundwater is connected to the little stream, and the little stream is connected to the bigger stream, and the bigger stream is connected to the bigger stream. And that goes into the river, which goes in the giant river, which goes into the ocean. And that's why the oceans are salty, because all of that comes off of the land, dissolves out of the rock. And the next thing to dissolve out of the rock is the molybdenum, or the calcium, or the phosphorus, or the potassium, or whatever else is in this rock. And eventually all of this is going to dissolve away. And where's it going to end up? It's going to end up in the oceans. And that's why there's sharks. That's where the nutrients come from. They come off of the land that fertilize the oceans, and so that the zooplankton, the phytoplankton, can get those little bits of nutrients out of the water and build their tissues. And then a larger zooplankton will eat that, and then a fish will eat that, and a bigger fish, and eventually it's a shark. And that's why there's life in the ocean. And what soil is somewhere between all of the nutrients being locked up inside of a rock and complete dissolution out in the ocean somewhere. Somewhere in between, there's this kind of intermediate moment where rocks sort of fall apart into different size particles of sand, silt, and clay. And when they dissolve out, those little bit of nutrients get taken up by a plant as a nutrient. And then if you eat that plant, or you eat an animal that ate that plant, or your mom did, and that's why you're here. So when I say it's all about soil, I mean all of it. Your entire experience of your whole life is predicated on this idea that nutrients, that rocks dissolve in water. And most people, they ironically go to their grave having never once considered the reality of that. I mean, sooner or later, every atom in your body is going to go back to the earth. And that's just the way it is, as it has done billions of times already. So what soil is kind of partially broken down rocks that have fallen apart. You see these different crystals? I mean, the last thing to dissolve out of a rock is the quartz, the silicon dioxide. And that's what sand is. And sand ends up on the beach there, and it moves around the earth, right? But all of the rest of it, if you want to go see ancient continents, whole continents that no longer exist, mountain ranges that have come and gone on this planet in the last 4.5 billion years, all you got to do is go to the ocean, go up to the water, and taste the salts in the water, and lift up the skeletons that are the sand in your hands. And that is where it all goes ultimately. And then it gets subducted into the subduction zone and comes up as lava, or it all uplifts, and those are the sedimentary rocks. And so we have all these different kinds of rocks. Like, for instance, I have this little sedimentary rock right here. Look what's in it. There's a clam in here. Can you see that? And this clam, I had Art Bucco, wonderful paleontologist who used to work here. He estimated that the age of this particular clam to be about 35 million years old. And this was found up at about 200-foot elevation, 300-foot elevation. So this was old, ancient marine sediments that were uplifted. And that's when soil starts to form. And sedimentary rocks, they dissolve away a little faster because they're slightly porous. You can see that. So that's basically, in a nutshell, that is how soils form. They form from dissolved rocks. And there's something else that we have to talk about, and that's organic matter. And I happen to have a bone here from a chicken, I think, or a bird bone from the wild. And here is like a rose. And this is just a dried rose. And what is organic matter? Because what soil is its minerals, but it's also organic matter. And what organic matter is, before we get to any of these slides, we have to talk about these basic things. What is a plant made out of? Well, what a plant is made out of is mostly, you might think, oh, soil, but no, really, mostly it's made out of carbon. And where does the carbon come from that makes a plant? And usually the correct answer is always soil, but in this case, it's the atmosphere. Most of you probably know that. Most people think, oh, plants, they take in carbon dioxide and then they exhale oxygen. No, they don't breathe carbon dioxide. They eat it. Plants eat the atmosphere and they take carbon dioxide apart and they put it together into a rose. So think about that. To take apart atmospheric carbon dioxide and put it together into tissues like leaves and roots and petals and seeds and all the things that make a plant and wood. To do that, to take that apart and put it together into these carbon-to-carbon bonds requires energy input. And where does the energy come from? Rhetorical question here. I know it's not, we don't have a crowd here, but you're all here. It comes from the sun. It's photosynthesis. 93 million miles away, there's a star that is giving UV radiation to this planet, and plants have figured out a way to capture that energy and use it to tear apart the atmosphere and put it together into these tissues. And in this tissue, inside of this carbon-to-carbon bonds in here right now, is the energy of the sun at the time of photosynthesis, is in here now. And maybe you never thought about this, but that energy is in there. And how do we know that energy is in there? Next time you're standing in front of a fire and you're burning wood, what is that? What happens to the wood in a fireplace? It slowly like goes away, right? It just goes away. Where is it going? It's going back to CO2, back to a gas. And it goes away. The wood just melts away and it gives off heat and light. And what is that? That's the energy of the sun. And when you're feeling that heat on your face and on your hands when you're sitting in front of a fire, that literally is the energy of the sun that was captured by plants during photosynthesis, plants that lived in soil. And that's where every beat of your heart right now, every beat of my heart right now is energy that was captured by photosynthesis by plants that lived in soil. Or we ate an animal that ate that plant, but still it's about plants. And if you think about it, what's left over in the fireplace after the fire is out, after all the fuel is gone? Ash. And what is ash? Ash doesn't burn. In fact, I happen to have, look at, what is ash? Ash are the mineral nutrients that the plant took up, the dissolved mineral nutrients that the plant took up. Look, I happen to have a piece of wood right here. This is a piece of wood that actually came from Brazil. And this was once a tree. And in this is the energy of the sun. And if I get this to 451 degrees, if I overcome the activation energy necessary for the oxidation reaction called burning to happen, it gives off the energy and it goes away. And if I just get this to 451 degrees, hopefully it'll work. That right there, that flame is the energy of the sun. Here's more paper. Here's more wood. You start a small trash fire here, right in this room. And look at that. And notice that the paper towel is going away. right? It's going away. Where is it going to? It's going back to CO2, water vapor, and heat. And you'll notice that what's left behind is this gray stuff right here. This tiny little bit of gray stuff right here. You see that? That's mineral. That's mineral ash right there. And it's just going away. And pretty soon there's almost nothing left except a little bit of ash. And so that's why you eat food. That's what you're doing. And how do you get a fire to burn hotter? You add oxygen, right? And so if we add oxygen onto a fire, it burns hotter. And the exact same chemistry is happening inside of you right now. In here, look, there's a hole here and there's a hole back here, and there's a tube going through your body. And you put organic matter into your mouth and you chew it up and you deliver it. You deliver it to bacteria. You know what the bacteria do? They ooze out enzymes that lower the activation energy necessary for the oxidation reaction called burning to happen, but at 98.7 degrees rather than 451 degrees, because they have catalysts and enzymes. And that's what's happening in you. You're warm inside now. Why is that? That's the energy of the sun. And the minerals that are left over, the ash, they are delivered to every cell in your body via the pumping of the blood and the heart. And that's energy that's actually doing that. And you are being built out of dissolved rocks using the energy of the sun to do that. Who thinks about that? And yet, it's absolutely it's the truth. It's a fact. Those are facts. And that's why you eat. Is you eat to get the energy from the sun that's in the carbon to carbon bonds from plants or animals that ate plants. And what's after it burns off. Look, how do you get a fire to burn hotter? Everybody together. Oxygen in, CO2, water vapor, heat out. Everybody together. Oxygen in, CO2, water vapor, heat out. And the ash is left behind. And those are the mineral nutrients. And that's what you're made out of. And that's really how the world works. We're on a rocky planet that is at a certain distance from the sun where there's liquid water, and liquid water dissolves rocks, which release the nutrients. And those nutrients are then taken up by plants from roots in their soil and taken up because of evaporation at their leaves that pulls those nutrients up. And then, I mean, even the DNA itself and the RNA that actually encodes the information on how to build all these tissues, even that is made from dissolved rocks. You're just a big bag of wet rocks. And it's almost over. And I don't mean this talk. I mean, your life, you're just here for a second. I mean, what's 70, 80 years in the scope of a 4.5 billion year old planet? You're really not even here. And yet here we are today together at this moment to talk about this. I'm honored to be here. I mean, I really am. So I do want to just share some slides with you. We can't only talk about we really needed to get there before we could move forward. So again, I'm going to talk about what soil is, but to talk more about it in greater depth, we really needed to get that. We needed to talk about that. And but before we do that, before we even move on, do you want to know what the answer is? Doesn't matter what the question is. Do you want to know what the answer is? The answer is add organic matter. Because when you add organic matter, what you're doing is you're adding carbon from the atmosphere and energy from the sun. That's what you do 3 times a day if you're lucky. And if you want to, I don't know if you know this, but in a single pinch of soil, I happen to have some soil right here. In a single pinch of soil, there are over 1 billion living organisms in a single pinch of soil. I dare you to remember that. I dare you to forget that in a single pinch of soil, there are over 1 billion living organisms representing tens of thousands of different species are in there right now. Every pinch you will ever experience ever again in the rest of your life. I just challenge you to comprehend the reality of that. This is where life on the planet is. By any measure, Soil is the most diverse habitat on the planet Earth by any measure. There are, by mass, there are more organisms living below ground than there are above ground. By sheer numbers, billions in a single pinch. There's a lot of pinches out there, folks. And just diversity. I mean, there are literally tens of thousands of different species in here. And what are they doing? They live underground. They don't even know there's a sun. They're just waiting for stuff to die, folks. They're waiting for plants to die. They're waiting for animals to die, because you know what they eat? They eat things that are, when they die, what's inside of these tissues? What's inside of this bone? Carbon and energy and calcium. There's energy in here, and it will burn. And you know what they do? They ooze out enzymes onto this, and that lowers the activation energy necessary for the oxidation chemical reaction called burning. And this will eventually rot away. And that's what rotting is. Rotting is just burning at a lower temperature with the aid of chemical enzymes, which themselves are made out of rocks. So, you know, put that in your pipe and smoke it, and just think about that. And just take a moment. All I ask is that one moment, in a private moment tonight before you go to bed, go outside and just get down on your hands and knees and just pick up a pinch of soil and just go 1 billion, and realize that this is you. You belong. You belong, and you are part of this, right? So moving on a little bit with our slides here. So our next slide should pretty much sum it all up. And that is, it's all about soil. What is soil? Soil is dissolved rocks that have fallen apart into different size particles, sand, silt, and clay size particles. And in between the sand, silt, and clay size particles are sand, silt, and clay size pores. And it's in the pores where the life is. In a large pore, maybe you don't know this, maybe you do, but large pores drain under the force of gravity. And like I have I can show you right now. And you've all noticed this, I'm sure. Let me get back to this. Yeah. You've all played with water, but look at this. Water, see how it holds in between there? I know this is not the greatest visual. See that little bridge of water there? Play with some water. Take a shower tonight, won't you? And notice that little bridge of water right there. Small pores hold water against the force of gravity, and large pores drain under the force of gravity. And different size particles have different size pores. And large pores, sandy soils, drain. And when they drain, when the soil is draining, when a raindrop goes down a wormhole, you know what's being pulled in behind it? Air. And so when the soil is draining, the soil is breathing. And plants at their roots, they need oxygen. You know when they need oxygen? All the time. So they need large pores. But plants also need water at their roots. You know when they need it? All the time. And so that's what soil holds water against the force of gravity. The basic laws of physics and the adhesion and cohesion and capillary force and gravity, all of that allow for water to be stored in soil even when it's not raining. Even though it's not raining, the plant still needs water. And how do they get it? They store it in the micropores, in those small pores. So just share my screen again here. So, I mean, I don't know if you know this, but there's over 20,000 different named soils. 20,000 different named soils. And they all belong to one of the 12 soil orders. So I don't know if you know that, but just like plants and animals have different names and there's different kinds, same thing with soils. And most people never think about any of this. But if you look on the left here, what you'll see is what's called an aridisol. What you're looking at here is a profile view, meaning if you dug a hole and you looked at the wall of soil. And here is what's called an aridisol, and that means arid, which means dry. And because it's dry, it means there isn't much water. And if there's not much water, that means there's not a lot of nutrients released, right? So in a dry environment, we have a lot of nutrients that are still in the rocks. And when it does rain, a little bit that it does rain, look at the water moves the salts down to about here, and then it stops raining. And so let's say it rains 6 inches a year here. So the salts are accumulating at about 12 inches deep. They never get to the water table because it doesn't rain enough here. And this is a salt pan here. And the soil here is actually only about 12 inches thick. And there's not a lot of nutrients released. And there's not a lot of water there. And to live there, you got to look like this. And that's what a native plant is. A native plant is adapted to the below ground environment as much as it is above the above ground environment. And in this below ground environment, there's just not that many nutrients available. And it's actually pretty salty and dry. We're over here on the right, what we see is a mollisol. And a mollisol, this is in feet here. And look at this big, thick, you see this big dark horizon here? We call that the A horizon. That's enriched with organic matter. And what is organic matter? Carbon from the atmosphere and energy from the sun, food for the billions in a single pinch. And this is at 2 feet deep. And this is caused by grass roots. And roots grow down into the soil and then they die. And then another generation that grows down into the soil and then it dies. And that keeps happening over and over and over. And pretty soon you got this big, thick chocolate cake layer of carbon and energy and lots of nutrients available here for the plants that live there. And the more plants live there, the more organic matter is added. The more organic matter is added, the better the habitat gets for the billions in a single pinch. The better the habitat gets for those billions in a single pinch, the better the habitat gets for growing plants. The more plants there are, the more sun and energy from the sun and carbon from the atmosphere there. And that's what soil building is. Soils build up over time with broken down rocks and accumulations of organic matter. So that's what a mollisol is. And I happen to have, let me show you, a bunch of monoliths here in this classroom today. And I want to show this to you. It's kind of cool. Since I have you here online, here, here in this room along the wall here, you'll come over here with me. These are all different soil monoliths, meaning these are actually mounted specimens of different soil types. And remember how I said there's 20,000 different named soils? These are just like 30 of them from Oregon. And they go from over here on the coast, on the west coast of Oregon, across here to the Willamette Valley. These are Willamette Valley soils. And then we get over here to eastern Oregon on this side. And they're different soils because they have different climates and they're made from different rocks, different what we call parent materials. And then the Willamette Valley, they came in by these giant floods, these biblical floods of biblical proportions that laid in all these sediments that came down the Columbia Gorge in these titanic floods. Whereas here's the coast range over here. So this is our state soil here. See, this is red soil here. And you probably have seen this. If you drive up in a little higher elevation, you'll notice that you'll get into these red soils. These are ancient basalt soils from basalt rock that was under the ocean hundreds of millions of years ago that eventually was uplifted, and it's been weathering and dissolving away for millions of years. And what's left here is mostly iron oxide. This is mostly rust. And where are all the nutrients? They washed away. So these are nutrient-poor soils because they're so old. So time is one of the master variables that determines, what kinds of soils are where. So the kinds of rocks, the kinds of sediments that soils form from, the climate that they live in, right? Also, and how old they are. Some soils are being formed right now. A landslide just happened somewhere in the Cascades just now. And it tumbled all the soil together, mixed it all up, and now it's kind of like starting over. And then a little bit of stuff lives and dies and lives and dies and lives and dies and lives and dies and lives and dies. And pretty soon you've got this horizon here that's enriched with organic matter. And then secondary minerals like clays are ending up accumulating down in here that dissolve and then recrystallize, dissolve and recrystallize. And it becomes a more organized habitat over time. What soil is habitat. If you get nothing else out of this talk tonight, if you can internalize the idea that soil is habitat, right? Let me see if I can get back to a video here. Okay. So look at this. Here's a map of the soils, of the soil orders of the earth. If you can see this. And we were just talking about mollisols. You see that? Mollisols here? And look where they are. Look, in the United States, 21% of our landmass are mollisols. Worldwide, it's 7%. That's all you really need to know about why you are living in the comfortable, technologically advanced state and lifestyle that you enjoy. It's because they who have the mollisols have the advanced agriculture. And they who have the advanced agriculture have the advanced technological societies. The society, and I mean, from the invention of agriculture allowed people to stay in one place and live off of surpluses and change. That changed everything. Once we lived in one place, that's when we started to write down things. You can't have public libraries and store information if you're always traveling. And before the agricultural revolution, which happened 10, 20, 30,000 years ago, depending on how you measure that, before that, people followed the animals and the seasons, and they lived in cycles where they moved around. Where after that, people just could live stationary, and they learned how to grow crops and have surpluses. And so that led to the invention, ultimately, of thermonuclear weapons. And they who have the mollisols control the planet. I mean, what other nation on this planet Earth has as much mollisols as we do? I mean, you can see it. Russia, right? And what do you think the Cold War was all about? I mean, what do you think the hot war is all about right now? Right here is Ukraine. Ukraine has some of the best soils on the planet Earth. And that's what this is all about. Look where the troubled regions of the world are, where the aridosols are. I'm just saying, what you're really looking at here is a map of political power, right? That's what this is. And it's all about soil and they who have the good soil. And how did we get this good soil? I mean, we know how we got the good soil. We took it the old-fashioned way. And, you know, that's what happened. And that's why we're here right now enjoying this moment of relative security and relative comfort, is because that happened. But we don't, you know, let's not dwell on it, but let's pay homage, a little honor to that, and realize that this country has a lot of really good soil because it has great grasslands, because of medium, not super wet, not super dry, not super hot, not super cold, and grazing animals for 20 million years made these soils here. So, I mean, we're already running out of time, aren't we? I do want to show some more slides and take some questions and get to something cool here. Bottom line, soil is habitat. If you get nothing else out of this talk tonight, if you can just internalize that soil is habitat and that a single pinch of soil has over 1 billion living organisms in it, and if you can understand that, you know what to do to it and what not to do to it, because it's a living thing. Soil is a 4-dimensional complex habitat, a self-organized natural body, a living thing, right? A single pinch has over 1 billion living organisms in it. And here, just looking at this, here's a tiny little piece of soil that's 0.5 millimeter by 1 millimeter high. And look at different size pieces of rock. These are sand particles here. And look at tiny little silt particles. And look at how the water is being held in here because of capillary force, like it holds between your fingers, right? This is a little ocean of water. And look what's in here. These different rocks are dissolving different nutrients into this water. And in between these three pieces of sand, there's an ecosystem here with a giant sea serpent living in there that's eating this thing, which is drinking the poop of those things, waiting. These things are waiting for all these things to die. And inside, between these three pieces of sand, is a complete ecosystem. And that we just live at the wrong scale. We cannot comprehend the complexity of life in the soil because we're just too big. We don't. I mean, up until maybe 100 years ago, we just didn't know any of this existed. Probably even less than that. What soil is a living thing. It's not a chemical sponge. And if you get nothing else out of this talk tonight, that would be really an important thing. So it is running out of time, and I'd love to chat with you more about what clay is, but I'd be happy to take a few questions or maybe if you want to direct the talk a little bit, I could talk about other things. I have some really cool stuff to show you from some really great tools that are online that I could show you. There's a plugin for Google Earth. We could look at soils. Any questions just kind of burning at the moment?
James, I think you can keep rocking it for another 10 minutes at least.
All right. Well, look here. If you can look here, I just zoomed in on Google Earth, and I have this, what's called right over here, if you look on the left, is the Soil Web plugin for Google Earth. And what this is all the natural resource conservation data that's out there. And you can like just zoom anywhere and look at what the soil types are. And if you look here on the east side of the Willamette River from downtown Corvallis, you'll notice there's old river channels here. You can kind of see these things. And if you just click anywhere in here, here's where the student farm is right here. And what we have is a Chehalis silty clay loam. And what this is a mollisol. That's why the student farm is there, because this is a great soil for growing. And like I said, there's 20,000 different named soils. And this is just one of them. And it belongs to the mollisol order. If we click on it and I go to Chehalis, we can see here at depth, we can see the A horizon. Remember I talked about the horizon that's dark in color? That's because there's a lot of organic matter there. And so it's down to 51 centimeters. That's a big, thick A horizon. And then there's B horizons underneath, just like those monoliths I was just showing you. And what's really cool about all this data is available for you for free. And you can get this information on your phone. And I'll show you how to do that in just a second. Look at, these are the native plants that are associated with this soil. And why do these native plants grow here? Because of the physical and chemical characteristics of this soil hold water a certain way and have certain temperatures and have certain nutrients that these plants can be found there. And look at here, we can see at depth, look at here's the percent organic matter. At the surface, it's about 8% organic matter, which is really high. I mean, if you have a soil that has 4% organic matter, you can pretty much grow anything. And this, as a native soil, has 8% organic matter at the surface, which drops down to about 3% organic matter at about 40 centimeters or so. Look at the percent clay and the percent sand. Here's the rate at which the soil water moves into the soil in millimeters per hour. So 32 millimeters per hour, it can flow into that. Here's the pH. And you'll notice these are all salts here. And there's no salts here. Why? Because all the salts dissolved and went down to the groundwater and went to the river and went out to the ocean. And that's why the oceans are salty, because they're not here anymore because it rains that much. And here's the CEC, which is the ability for the soil to store and release nutrients. And if we just go to the other side of the river, or maybe go to another part of the state, like on the other side of the Cascades, and we zoom in here, and we'll see what kind of soils here. We can see there's agriculture being done here. And let's see what kinds of soils are there. And so this is, I want to show you how to get this tool, because I think it's really powerful for you to be able to know what kind of soil you have. Look at these different soils here. So we'll click on this one here. So this is an aridisol here. It's a vitrandic argyurid. So it ends in id. That means it's an aridisol. And vitrandic means it's glassy. And so this is a pumice, right? Because it's on the east side of the, well, it doesn't have an actual description of that soil, on the east side of the Cascades. So here's one called Boyce. It's a type of soil. Look at the salts. Do you see there's some salts in this soil? There's some calcium carbonate that accumulate there because it doesn't rain that much. It's got pretty good organic matter. It's about 30% clay. And here's the pH. Anyway, so that goes on and on. There's 20,000 different named soils to look at there. And we're not going to look at them all. But I do want to show you how you can get this on your phone. And I think, I'm sorry, I had this camera on this the whole time. I do want to show you how you can get this on your phone. And you could all do this right now. It might be the only reason to have a smartphone. So if you got a smartphone, come have a look and I'll show you how to do this. Okay. And you can, and I would like to know what, I know Guy comes and does a talk on Zoom that was supposed to be live and then brings out his phone. Okay. Forgive me, won't you? And all you got to do is go to the App Store and type in soil web. It's one word. Do this. I dare you to do this right now. Soil web. One word, and search for that. And there it is. Soil web. It's right there. And you could get that. I already have it. And I'm going to open it up. And what it looks like, I'll just get it right here right now. And what this will do is it'll geolocate and tell me what the soil is under my feet. And this is what's under my feet right now, is a soil called woodburn. And the reason the university is here, the reason I am in this place on the planet Earth, and the reason the university is here, because there's a woodburn soil here. And this building is sitting on top of what used to be the farm. This used to be the farm here. And then as the university got bigger, they paved it over and put buildings here. And if we look at woodburn soil, there's a whole description of what it is. And here, if you click down here, here's the description. If you look at the bottom, right down here, see where it says details down here? You just click on details and you can get the soil properties of this soil. And here's the percent organic matter at depth. Here's the percent clay at depth. Here is the percent sand, etc. And really, and there's more that you can look at. You can look at things like the land classification, the hydraulic erosion ratings. But what I urge you to do, I just urge you to download this app, and wherever you are, every time your phone rings, just check the soil first, would you? Has anybody who can offer me the name of a soil right now? That has anybody done this? I'm just curious. Come on.
Nat Roy.
What do you got?
Nat Roy.
Okay.
NATROY.
Hey, we're gonna get there. We're gonna look at it. Where is I need to get to, hold on a second. Hold the phone, so to speak. It is right. Right here. Okay. So all you have to do, and what is it called again? How do you spell it?
It's the Nat Roy Urban Land Complex.
Well,
Is the map unit.
Downtown Eugene, I'm guessing, right?
Up in the hills.
Up in the hills. How do you
NATROY.
NATROY soil. We'll just put that. We'll see what comes up. NATROY. Here's the Natroy series. All I did is just type in Natroy and soil. And that's one of the 20,000 different soils is right here. The Natroy soil consists of very deep, poorly drained soils that formed in fine textured alluvium. What alluvium is it came in by the river. So you're probably near a river that at one time flooded there. These are on terraces and fans that have slopes of 0 to 2%. And the mean annual precipitation is about 45 inches and the mean annual temperature is about 53 degrees Fahrenheit. And so wherever you are, so play around with that and learn about it. Always just be learning about the different soils in your area. What you'll notice is many of them have names that I don't know if you've ever heard the name Natroy before. I have not, but I don't live around down there. So definitely do that, get this soil app and see what your soil is. And you might be wondering, wait a minute. So are you telling me that that they've mapped all the soils in the country? And you know what? They have almost all of them. They didn't check every square inch of the country, but what they did is they went out for the last 100 and 150 years, and they went out and they mapped geology, topography, climate, types of vegetation there, and how old those landscapes are. And they drew lines where they thought there were different soils, and then they dug holes and they actually did profile descriptions of 20,000 different named soils. And they're constantly adjusting that map, and that information is all available to you for free on your phone or as a Google Earth plugin. So fascinating. I do want to just go a little further here. I want to, if there's another question, I'd be happy to take one. Just want to get to the end here. Anything else? All right. Well, it's almost 8 o'clock. I'd be happy to keep going, but you might be wondering. I mean, check this out. So here are, these are the nutrients. Check this out. So if you look at, these are the essential nutrients plants here. And look at this: calcium, molybdenum, silica, magnesium. These are all dissolved NP or P and K. These all dissolved out of rocks. Right. And look what they do. They do things in the plant, like phosphorus, really important for fruit quality. Copper is important for fruit flavor. Here's iron as an oxygen carrier. Here's promotes reproduction. Right? All these things do different things in the plant, and there's not a whole lot of these things in plants. Because remember, after the fire is out and that little bit of ash is left, that's not a lot of stuff. Mostly it's carbon and water and energy from the sun. And then we eat these things, and look what they do. They do stuff in us, and actually they do a lot of the same things. They have these functions, and then of course, all this stuff, all things that were once alive die, go back into the soil, where the billions in a single pinch will take apart every atom and take us completely apart. And those nutrients will be recycled again and taken up by plants, as has happened, billions of times already.